I'm Dr. Fakir Raveri, and this is an overview of influenza activity in the United States, week 12, 2024. Here's an overview of what's in the influenza vaccines over the past 4 years. Essentially, there are 4 different strains, strain 1, 2, 3, and 4, which are in the quadrivalent vaccines, and there are 3 in trivalent vaccines. Since 2021-22 seasons, all vaccines have been quadrivalent. Previously, we had a combination of either trivalent or quadrivalent. So essentially, the first 2 strains are influenza A. So the first one is a H1N1 influenza A. The second strain is a H3N2 influenza virus strain. And then strain 3 and strain 4 are influenza B. So strain 3 is a Victoria lineage and strain 4 is the Yamagata lineage. And there are 2 sets of vaccines each year. So essentially the egg-based vaccines, regardless of who the manufacturer is, have the same strains, whereas cell-cultured and recombinant vaccines have slightly different compared to the egg-based, but essentially the same strains in cell-cultured and recombinant. And you can see that compared to the previous season, what was updated in 2023-24 season was the first strain. So influenza A H1N1 was updated compared to the previous year, whereas the other 3 strains will remain the same from the previous season. Now, these vaccines get updated based on what was seen circulating in the previous season and what's predicted to predominate in the upcoming season. So these are typically determined by the WHO ahead based on the southern hemisphere. And essentially, it takes about 6 months for these egg-based vaccines to get manufactured. So ahead of the flu season, these things get predicted and get manufactured. And then throughout the flu season, we find out what's actually circulating and how well the vaccines perform. So at the end of the last flu season, so this was around May of 2023, essentially what was circulating, which was not a lot, because flu season was over by then. Essentially, it was, what was available was sequenced, so if, specifically for influenza A, and essentially was determined what was the most dominant in order to determine what should go into the influenza vaccines. So essentially for H1N1, it was determined that 2A.1 would be the predominant, and for H3N2 would be the 2A.2b. And based on that, H1N1 was updated for the current season and H3N2 was not. So that's why you will see that this is 2A.1. But essentially for H3N2, it remained unchanged. Now, as we enter through the flu season for the 2023-24 season, we can see that up to week 40, 41, the flu activity was pretty low, so under 2% positivity of all the specimens. And as we went through October and then through November, flu activity started to pick up in November, so went past the 2% positivity rate, 3%, 4%. And by the time we got through 2024, it had started to go down to 15.7%. So because what I'm not showing you here is the peak activity, but then started to go down throughout 2024. So slowly going down through March, and essentially week 12, which is the latest data available right now. So this is the data ending on March 23, and out of 77,000 specimen, 10.5% tested positive for influenza. Pretty much half of it influenza A, half of it influenza B, and for H1N1, 75% of it is 2A.1, which is essentially what's in the vaccine, and 24%, 25% 2A. which is from previous seasons. And then for H3N2, essentially 28.2 is what was in the vaccine, but we have seen several different subgroups emerge. So essentially, we're not sure if the current vaccine is active against these. It may very well be that it is. We just don't know yet. So I haven't seen studies looking in vitro studies to see if the antibodies from the vaccine can actually neutralize these. But essentially 99.7% of it is the subgroup 28.38.1 that's circulating right now. Now, fortunately, mortality rate has been under 1%, so around 0.7% mortality rate. Now, when we look at the flu season overall, you can see that it peaked around week 52 and then started to go down. So, right now we're about 10% positivity rate, and this is week 12 right now. So essentially, so far about somewhere between 31 to 58 million have had the flu, and about 14 to 27 million people actually had to seek medical visits due to their flu, and about 350,000 to 720,000 people had to be hospitalized, and unfortunately 22 to 63,000 people have died from the flu this season. Now, when we compare the current flu season to previous seasons over the last 10 years or so, we can see that the red line is the current flu season, which is kind of aligned with most flu seasons. So it didn't start too early like last year. And it didn't go on this graph. We're looking at the rate of hospitalization. So on the x-axis, we're looking at different weeks throughout the flu season, and on the y-axis, we're looking at the rate of hospitalization due to the flu season, due to the flu. And we are seeing that. So although the rate of hospitalization has been pretty high, but not as high as the 2017-18 season. However, this flu season is not over yet, so we have entered April, and positivity rate is still pretty high. So hopefully the rate of hospitalization will start to go down as opposed to continue to go up, but that remains to be seen. In this graph, we are looking at the mortality rate. So essentially, we are looking at the past 4 or 5 flu seasons. And on the y-axis, we're looking at percent death. And you can see that, the rate of mortality is going down as the flu season coming to an end. But, so relatively seems to be less compared to last year. But again, the flu season is not over yet. So this is yet to be seen how it will conclude. Now, when it comes to our antiviral agents, in general, resistance to antiviral agents is not common. However, there were a couple of strains that showed resistance to oseltamivir. So specifically, the H1N1 strain that showed resistance, but not H3N2. There were also a couple of H1N1 strains that were resistant to pramivir. None of the strains were resistant to zanamivir, and although no H1N1 was resistant to baloxavir, there was one strain of H3N2 that showed resistance to baloxavir. So, but in general, resistance is extremely rare. So that is a good news. Now, looking forward to what's to come for next flu season, so the 2024-25 flu season. So of course, based on what we saw, influenza A H1N1 will remain unchanged because what's predominantly circulating is in fact what's in the vaccine. So that will remain unchanged. And what will change is the H3N2 strain will actually get updated to reflect what was predominant this season. So it will be the 2A.3A.1. Now, influenza B Victoria lineage will remain unchanged. Now, one thing that will be new next year is that because Yamagata lineage has been eradicated for a few years now, we're actually going to remove it from the flu vaccine. So next year, all vaccines will be trivalent because strain 4 will actually be removed. As you can see, the Yamagata lineage, the strain has not changed in the vaccine for many years. In fact, we have not seen strain circulating for a few years, so there's really no need to include it in the vaccine anymore. Now let's take a look at what happens to vaccine effectiveness when there is a mismatch between what's circulating and what's in the influenza vaccine. So this study looked at vaccine effectiveness against influenza hospitalization, specifically due to influenza A H3N2, and this looked at this study was actually published in November of 2022. So it looked at what had happened during the 2021-2022 influenza season. And the vaccine for that season included an H3N2 that was 2A.1 like. So as we can see, in 2021-22 for H3N2, there was the .2A, which at the time it was not called 2A.1, it was just called 2A, and then later when different subgroups emerged, then it became 2A.1.2. They looked at adult patients aged 18 years or older who were hospitalized due to acute respiratory illnesses, and that included 2,334 patients that were hospitalized. And of these, 295 of them actually had influenza, and 47% of these patients were vaccinated. Now, they used two control groups. One control group had neither influenza or SARS-CoV-2, and there was another control group that did not have influenza, but they had SARS-CoV-2 infection, and that's the reason they were hospitalized. And pretty much almost half of these patients were vaccinated against influenza. What they found was that influenza vaccine effectiveness against hospitalization was actually pretty low. So it was 11%, and in fact this was not statistically significant. So 95% confidence interval went from negative 19% effective to all the way to 33% effectiveness, which did not reach statistical significance. The same results when you looked at subgroups of adult patients over the age of 65, again, vaccine effectiveness was not significant. For adults 18 to 64, there was also no significant effectiveness. In adults 18 to 64 with immunocompromising conditions specifically, of course, no significant. But interestingly, when they looked at age 18 to 64 without immunocompromise, there was actually a benefit to vaccination, even though the vaccine did not match what was circulating during that season. So there was a 50% vaccine effectiveness in relatively younger adults without immunocompromising. So this essentially means that these patients are more likely to have a robust immune response to the vaccine, and even when it's not matching exactly what's circulating, these patients can benefit. And when you look at the other patients that are less likely to have a robust immune response to the vaccine, so those who are relatively younger but have immunocompromising conditions, or elderly patients over age 65, when there is a mismatch, they're not going to have enough immune response to the vaccine to protect them. So that's the reason why it's really important for the vaccines to match what's circulating during the flu season in order to protect those people who really need protection. And that's, elderly patients and younger patients with immunocompromising conditions. Now, when they looked at the more important outcome of ICU admission, they saw that a lower proportion of vaccinated compared with unvaccinated case patients required ICU admission, which was statistically significant. So even when there is a mismatch between the vaccine and what's circulating, there can be significant benefit as far as prevention of ICU admission, even if patients are hospitalized. This is a forest plot of all the subgroups. So you can see at the top, this is the overall results, which crosses the line of unity, so it's not statistically significant. And you look at all the different subgroups based on age, based on immunocompromise or immunocompetency. You can see that pretty much all of them did not reach statistically significant, except the group that I mentioned, that are relatively younger patients who are immunocompetent. Some other outcomes that were compared, you can see, of course, I just mentioned admission to ICUs was significantly lower in vaccinated patients versus unvaccinated. So this was significant. But the rest of the outcomes did not reach statistical significance. That included low flow supplemental oxygen requirement, high flow nasal cannula requirement, a non-invasive positive pressure ventilation, invasive mechanical ventilation, vasopressor receipt, or in-hospital death within 28 days. Although numerically more people died in the unvaccinated group, so 3% versus 1%, but these numbers were so low that they could not reach statistical significance. Now, potential reasons for lack of significant vaccine effectiveness in this article were one was predominant circulating virus was antigenically distinct from the vaccine virus, as I mentioned. Another reason could be ongoing egg adaptation mutations in influenza A, H3, and 2 during vaccine manufacturing, such that the vaccine strain may elicit antibodies to sites that are unavailable in circulating viruses. This is why it's been suggested that non-egg based vaccines could potentially have better vaccine effectiveness because they don't have this issue of egg adaptation mutations. Another reason was older adults were imprinted with influenza A H1N1 since it was the only subtype circulating in humans from 1918 to 1957. Consequently, their immune response may be biased toward H1N1 and away from H3N2, which emerged in 1968. So, of course, this study was evaluating vaccine effectiveness against H3N2 specifically. Another reason could be younger adults were more likely to have been imprinted with H3N2. So same argument, on the other side of the table. And lower vaccine effectiveness in older adults, of course, might be related to immune senescence, inflammaging, and diminished effects of repeated vaccinations that might occur among older adults. Now let's take a look at what happened to vaccine effectiveness during the 2022-2023 influenza season. Now during this season, there was a good match between what was circulating and what was in the vaccine. Specifically for H3N2, now the vaccine did include 2A.2, and that is indeed what was circulating. So for 2022-23, that was actually what was updated. One of the two updates for the vaccine was that H3N2 was updated to 2A.2. There was also an update to the Victoria lineage, and influenza H1N1 strain remained unchanged. And this study that was published in December of 2023 looked at adults aged 18 years and older who were hospitalized with any acute respiratory illness, and they were tested either by antigen or molecular assay for influenza, and it was 3,707 patients who were hospitalized. 714 of them actually had influenza, and the remaining patients who were influenza and SARS-CoV-2 negative served as controls. So there were 2,993 controls, With the influenza cases, 33% were vaccinated. With the control, 49% were vaccinated. And they essentially found a significant vaccine effectiveness against hospitalization. So now that there was a match, and this is overall, both H1N1 and H3N2, so any of the two strains of influenza A. So vaccine effectiveness against hospitalization due to influenza A was 37%, and confidence interval went from 27% to 46% effectiveness. So that was statistically significant. It did not cross 0. Now, unfortunately, it's not high enough, right? So it's approaching 40%. So it's not too high of a number that we'd like to see, but still some effectiveness. So it protects many patients. In particular, for elderly patients, vaccine effectiveness against hospitalization was 28%. That was statistically significant. For younger patients, still significant, so 47% effectiveness. Now, when you look at the different strains, so H3N2, the vaccine was pretty effective, statistically significant. So was, against H1N1. So across the board, statistically significant. So that's what happens when we have a good match between the vaccine and what's circulating. And it didn't make a difference if patients were immunocompromised or immunocompetent, still significant. Now, when we look at subgroups, you can see across the board pretty much statistically significant. The only exception was, if you look at elderly patients for H3N2, this confidence interval was too wide, so it crossed the line of unity, so it did not reach statistically significant, but pretty much all other subgroups reached statistical significance. Now, when we look at some of the outcomes in the hospitalized patients, you can see that for some of them were statistically significant, so the need for invasive mechanical ventilation, so the vaccine had a protective role against that was significant. The use of acute vasopressor, so essentially vaccinated patients were less likely to need mechanical ventilation and less likely to need acute vasopressors. And they were also less likely to have a need for acute organ support, and less likely to be admitted to the ICU. Now, it did not make a difference as far as mortality. Mortality overall was low, but you can see numerically more people died if they were unvaccinated. However, that was not statistically significant. When we look at some of the other outcomes they looked at, for example, hospitalization, the vaccine was highly effective. Of course, that was the overall result that I just went over. But some of the other ones that were secondary outcomes, so the need for oxygen support, the need for respiratory, cardiovascular, renal failure treatment with organ support, these are all statistically significant. And of course, the last one that did not reach statistical significance is mortality. You can see this wide confidence interval. However, the point estimate still is in favor of vaccine effectiveness. Now, let's take a look at pediatric patients. So during the same season, 2022-2023, there was a good match. This study looked at vaccine effectiveness against pediatric influenza A associated urgent care, emergency department, and hospital encounters. And what they found was that the vaccine was significantly effective against all of these outcomes. So 48% vaccine effectiveness, that was statistically significant. And when you look at hospitalization alone, the results hold statistically significant vaccine effectiveness of 40% against hospital admission for pediatric patients aged 6 months through 17 years of age. And when you look at the specific subgroups by age, so essentially going from age 6 months to 4 years, the results hold. Vaccine effectiveness against hospitalization, and for the age group 5 to 8 years, the results hold the same as older pediatric patients aged 9 to 17. So that is really promising that the vaccine works really well for our children. And this graph that I just covered, it was emergency, deferment, and urgent care encounters. And then when you look at hospitalization specifically, you can see that the results hold that there was significant vaccine effectiveness against hospitalization. Now, since there was a concern about mutations in the hemagglutinin protein during egg-based manufacturing that can result in mismatch between selected strains and the vaccine strain, there was a randomized control trial that compared recombinant vaccines versus egg-based vaccines in essentially non-elderly patients, so age 18 through 64 years. So it was over 1.6 million patients were included. However, the primary outcome was specifically in patients aged 50 to 64 years. So that was about 675,000 patients that essentially were randomized to receive either an egg-based influenza vaccine or the recombinant high-dose recombinant. So the egg base is actually the standard dose and the recombinant is high dose, and this was done over 2 seasons, so 2018-2019 and 2019-2020. Now there is a dose difference because, as you know, the large majority of the vaccines on the market are egg based, and for adults essentially the dose is 15 micrograms. Now, when you look at, so that's the standard dose egg base. The high dose egg base, which is for elderly over age 65 and older, has a higher dose as the name implies. So that's 60 microgram. But the rest of adults under age 65, they receive 15 microgram. Now, what's unique about recombinant is that not just the technology for manufacturing is different, so it's not egg based, but also the dose is also 3 times as much as the regular egg based. So it's 45 microgram instead of 15 microgram. So essentially there's 2 advantages. One is that you're not gonna get the mutations that occur during egg based manufacturing, and also you get the benefit of the higher dose. So the question is this going to result in difference in outcomes? So what they found is that there is indeed increased vaccine effectiveness. So this is compared to the other vaccines. So in addition to the vaccine effectiveness that you get from vaccination, if you get recombinant instead of egg-based, there is an increased 15% effectiveness against influenza infection, and that's statistically significant. However, the results are not significant when it comes to hospitalization, so it doesn't make a difference for hospitalization and other outcomes. So you look at subgroups, including people with comorbidities. You can see that the confidence intervals become really wide for these because they're essentially you're breaking into too many groups. So essentially, the first set of groups is for influenza infection itself. So you can see specific subgroups doesn't make a difference, but when you collect them all together, there is a statistically significant in favor of recombinant vaccine. However, I would point out that the point estimate for all of these subgroups are in favor of recombinant influenza vaccine. For hospitalization, again, all these subgroups, you will see that it does not make a statistically significant difference because the confidence interval crossed the line of unity, including when you collect all of them together for hospitalization, it doesn't make a difference. But again, the point estimate for each of these outcomes is in favor of recombinant vaccine. And the last one is hospitalization for community-acquired pneumonia, not just for influenza. And again, no significant difference, but again, point estimate is in favor of recombinant vaccine. So I will leave you with this statement. Since standard dose vaccines prevent at most 40 to 60% of influenza cases annually, reducing the incidence of breakthrough influenza by 15% would provide a substantial public health benefit, especially during more severe influenza seasons. CDC recommends routine annual seasonal influenza immunization for all persons aged 6 months or older who do not have contraindications. Now, there are no preferential recommendations for one influenza vaccine product over another, except specifically for adults aged 65 years or older, which we will cover on a later slide. Now, in general, it takes about 2 weeks on average for the body to fully respond to the vaccines and mount antibodies, so keep that in mind. And vaccination should be offered during September and October and continue through flu season while unexpired vaccine supplies last. And for non-pregnant adults, early vaccination, for example, when the vaccine becomes available in July and August, should be avoided unless there is concern that the later vaccination might not be possible. So, if somebody's in their third trimester in July, for example, they may go ahead and receive the vaccine. We'll talk more about vaccination during pregnancy on a later slide. And of course, COVID-19 vaccines can be co-administered with influenza vaccines. It's been shown both safe and effective. Now, here's a summary of the available products for this influenza vaccine season. We have one that's a live attenuated influenza vaccine, so FluMist. Historically, the live attenuated vaccine has performed poorly compared to the inactivated vaccine. So for that reason, it is only recommended for persons aged 2 years through 49, because anybody under the age of 2 or age 50 and older is at risk of complications from influenza infection. So therefore, for those people, we want the better vaccine, so the better more effective vaccines that are pretty much everything else in this table. Next, we have inactivated influenza vaccines. Now, traditionally, we have the standard dose. So this is 15 microgram shots. And we have several different formulations from different manufacturers available. Now, these are all IM injections, whereas the FluMist, the live attenuated, that's actually a nasal spray. So it's actually helpful for people who are afraid of needles. For these inactivated influenza vaccines, these are essentially all of them are quadrivalent. So when you see a number, the number 4 means that these are quadrivalent. As I mentioned earlier, we only have quadrivalent available on the market nowadays. Next, we have cell cultured. So the previous vaccine that I mentioned, they are all developed in eggs. So, essentially chicken eggs are what's used to grow these vaccines. For the non-egg based, we have the cell culture. So cell culture essentially uses mammalian cells to grow as opposed to the egg cells. We have one product, FluCellVax, so it's kind of in the name cell. So it's cell cultures, FluCellVax. And it's also quadrivalent. Pretty much these are for age 6 months and older. We also have recombinant influenza vaccine. So this actually uses recombinant biotechnology to make these in a lab. These are essentially developed in some bugs inside the lab. And FluBlock is the formulation that's available. However, keep in mind that this is only approved for age 18 years and older, so they may not be used in children. And then, specifically for elderly who typically respond less to the vaccines, we have a few formulations that boost the response. So one is adjuvanted inactivated influenza vaccine. So this uses adjuvants to increase immunogenicity. So FluAd, so ad is in the name, adjuvant, and this is for age 65 and older. And we also have the traditional inactivated influenza vaccine in higher dose. So HD is for higher dose. So instead of the 15 microgram, this would be essentially 60 microgram. So that's a higher dose. Now I will mention that the recombinant influenza vaccine also has a higher dose compared to the inactivated influenza. So instead of the 15, it uses 45 microgram, but it's still less than the high dose, which is 60 microgram. Now I mentioned these because these will be essentially these three at the bottom will have higher efficacy in elderly. So essentially everything is made through eggs except recombinant and cell culture, which brings us to the question, what if the patient has egg allergy? Because some of these egg proteins might be in the vaccine. Although not common, you may come across patients who have egg allergy. As I mentioned, majority of the influenza vaccine formulations are grown in eggs. Both cell culture grown and recombinant influenza vaccines are considered egg-free. The recombinant vaccine utilizes recombinant DNA technology to manufacture the vaccine, and the cell culture grown vaccine utilizes mammalian cells instead of eggs. So should we only give recombinant influenza vaccine to patients with egg allergy? Well, first, it's important to know that CDC recommends considering patient observation for 15 minutes after administration of any vaccine, not just the flu shot, and regardless of whether they have had allergies or not. Secondly, regardless of reaction to egg exposure, even if anaphylaxis, the recommendation is that all persons aged 6 months or older with egg allergy who do not have contraindications should receive any licensed and recommended influenza vaccine, including the egg-based vaccine. The bottom line is that egg allergy is not a contraindication to receiving egg-based influenza vaccine. Now, what if the patient had allergy to a previous influenza vaccine ingredients and not just egg allergy? We can consider 3 different groups. So one would be people with an allergy to egg-based vaccine. The second group would be people with allergy to cell-cultured vaccine. And last would be people with history of reaction to a recombinant vaccine. So in general, when the CDC says precaution when it comes to allergies, use should occur in an inpatient or outpatient medical setting under supervision of a provider who can recognize and manage a severe allergic reaction. And of course, vaccine components can be found in a package insert. So for the first group, those who have allergy to egg-based influenza vaccines, any egg-based vaccine, it's contraindicated for these patients. However, they may receive a non-egg-based vaccine, so either a cell-cultured and recombinant. Now, again, this has nothing to do with eggs. This has to do with allergy to an egg-based vaccine. Now, for the second group, who, if they had an allergy to a cell-cultured inactivated influenza vaccine, any egg-based is contraindicated as well as the cell culture vaccine. However, they may receive, cautiously a recombinant influenza vaccine. And of course, last group, if they had a history of allergy to recombinant, again, egg-based is contraindicated as well as recombinant influenza vaccine, but they may cautiously receive cell-cultured influenza vaccine. And of course, if it is unknown which influenza vaccine they had a reaction to, then an allergist can be consulted to figure out if it's okay for the patient to receive a vaccine. Now, what are vaccine considerations during pregnancy? So persons who are pregnant or postpartum should receive any inactivated influenza vaccine or recombinant influenza vaccine, as long as this is before or during the flu season, and can be given before pregnancy and during all trimesters of pregnancy, but in general, limited data during the first trimester. The live attenuated vaccine should not be used. It's actually contraindicated during pregnancy. And in general, there is less experience with more recently licensed inactivated influenza vaccines, such as all the quadrivalents that are available on the market and the cell cultured based vaccine. And there is limited data with recombinant influenza vaccine. Now, for immunocompromised patients, the same recommendation is made. So either inactivated influenza vaccine or the recombinant, and of course, inactivated either egg-based or cell-cultured, similar to pregnancy. And live attenuated should not be used. So the live attenuated, because they replicate in the body, they should not be used immunocompromised because it can replicate, and get out of control due to immunocompromise. Last, what if the patient is taking influenza antiviral medications? Now, administration of inactivated or recombinant is not affected by antiviral agents. However, if somebody is to take the live attenuated because that vaccine needs to replicate in the body, antiviral medications will affect the vaccine efficacy. And when it comes to our antiviral agents used for the flu, the half-life makes a difference. So, some of these, such as Pramivir and Baloxavir, have much longer half-life, whereas oseltamivir and zanamivir have shorter half-life. So in general, the live attenuated influenza vaccine will have reduced effectiveness if oseltamivir is taken within 2 days before and up to 14 days after. So in other words, if somebody is taking oseltamivir for an actual infection or for either prophylaxis or whatever reason, and they are to receive a live attenuated, they should wait 2 days after discontinuing oseltamivir to start vaccination. And then once vaccination is given, they should wait at least 14 days before they can receive, for whatever indication, another dose of oseltamivir. And the same concept applies to Pramivir and Baloxavir, but the timing is different. So for Pramivir, 5 days before and up to 14 days after. The 14 days is because it takes, on average 2 weeks for the vaccine to kick in. So once it's given, regardless of which one it is, you want to wait 14 days for the vaccine to replicate and mount a response. And then the other ones, the 2 days, 5 days, and 17 days, you essentially waiting for these drugs to be cleared from the body based on the half-life, and then give the vaccination. Now, what if the patient is elderly, and that's defined as age 65 years or older? So there are 3 preferential recommendations. So either the high dose inactivated influenza vaccine or the recombinant influenza vaccine, which essentially has a higher dose than the standard dose inactivated influenza vaccine, or an adjuvanted inactivated influenza vaccine. And of course, they do say that if none of these are available in the pharmacy, then any other age-appropriate influenza vaccine should be used. So any vaccine is better than no vaccine. So you don't want, in other words, if somebody's at the pharmacy and these 3 are not available, you do not want to, order it and have the patient come back, because there is a good chance that they may not come back. So any opportunity to vaccinate individuals is very important, because any vaccination is better than no vaccination. And the reason these 3 are preferred over others is that, for one, the high dose was studied against the standard dose, and these are specifically in the trivalent vaccines, where they did the randomized controlled trial, and they found that the high dose was superior to the standard dose. Specifically, it had about 24% greater relative efficacy compared to the standard dose. And when it comes to recombinant, compared to the standard dose, again, recombinant has a slightly higher dose in it. So in elderly, they also saw higher efficacy, so about 30% greater relative efficacy compared to the standard dose. And of course, the adjuvanted FluAd uses MF59 as an adjuvant to increase immunogenicity, which showed about 63% greater relative efficacy. Thank you for tuning in. If you enjoyed this video, make sure to subscribe and like this video.